And here's question number 1. It's multiple select. Which commands on their own can auto-generate some type, any type of IPv6 address? And all of these answers are absolutely true. And here's what I'd recommend. Packet Tracer, as many of you know, is absolutely free. It's available from netacad.com. And here's what I recommend. Just take 2 routers, call it 1 and 2, put a link between them in Packet Tracer, and then do a no shut on both of these interfaces, and then try them out. IPv6 enable, and then once you do that command, just do a show. You can do a do in front of it, or you can exit out of configuration mode, show IPv6 interface, and then like gig 0/0, whatever the interface is, and it will show you the IPv6 addresses. This is going to give you a global address and link local. Well, it's going to give you a link local address for sure, which is auto-generating an address. This is also going to give you an auto-generated link local address. This also is going to give you a link local auto-generated address. And this also is going to give you an IPv6 link local address. So there's 2 addresses usually on an interface, a global address that can be routed anywhere in the world, and also a link local address that's only going to be valid and usable on this network segment. And that would be the one that starts with FE80. That's a link local address. So test that out. And that way you'll better understand and have appreciation for it. It's really simple. It'd take less than 5 minutes for you to do that hands-on exercise. And I encourage everybody to do it. All right, let's see who is in the winner's spot after the first question. Lucky Tiger, 3,748 points. If you are brand new to these quizzes, the way it works is this. The faster you answer correctly, the more points you get. And so the goal would be to answer them as quickly as possible, as correctly as possible, to get the most possible points. All right, here we go. That's just question 1. And here's question number 2. What is the correct syntax to back up the OSPF version 3 route? Now, just if you aren't familiar with OSPF version 3, that's the OSPF flavor for IPv6. And so what I'm really asking is, how do you create an IPv6 floating static route to back up the OSPF learned route? So IPv6 route, the reason, if we went back to the media, the current route it had an AD of 110. And so if we had another route, a static route, with a artificially higher administrative distance, like 155, it would just be sitting in the wings, not in the routing table, until the OSPF learned route went away, and then this route would be injected in the routing table. And that's a floating static route. The same concept applies to IPv4 and IPv6. All right, 48 of you nailed it. Way to go. All right, moving forward, let's see who's on the leaderboard here. Ooh, Lucky Tiger. All right, moving forward, here's question number 3. It's multiple select. Which 2 commands, I'm only looking for 2 specific answers. Which 2 commands will auto-generate an IPv6 address with information from the MAC address on that same interface? Well, there's the answers, and let's talk about that for a moment just to confirm. IPv6 address, FD, no, FD, FC, if it starts with FC or FD, that is a unique local address. It's a unique local address. That means it can be routed in your infrastructure, sort of like an RFC, like a private IPv4 address like 10 or 172.16.231 and so forth. So if you see these first 2 characters of FC or FD, that simply means it can be routed in your enterprise, but not over the public internet. It's a unique local address. So this one here, if we did this, it would automatically in the background create for us a link local address. And that link local address absolutely is going to take the MAC address. It's going to split it in half. It's going to put 24 bits here, 48 bits, yeah, 24 bits here and here. And it's going to have FFFE in the middle. And then it's going to flip the 7th bit of that first portion for the host address. So that's why this is true. We're talking about the link local address it's going to create. And then down here, oh yeah, and this one, it's actually going to use the MAC address for both of them. For this one, for the globally routable address, addressing that starts with 2000 through 3FFF. If you see those in that first number position, that means those are routable across the internet with very few exceptions. And because we're using EUI64, it's saying that we're going to use the MAC address and play this game up here to go ahead and create the host portion of that address. And it's also going to do the same thing for the link local address as well. Over here, oh yeah, so right here, red, got a few in that. So if we specify manually a link local address, which start with FE80, and we specify exactly what it is, that's not going to create a globally routable address for us. It's just hard coding the link local, and it's not using the EUI64 at all there. And then this one down here, what's wrong with this? Oh, let me talk about green. Got a lot of people on green. The reason that green down here is not correct is because we're saying, hey, use EUI64 for the host portion, for the host address, the back 64 bits. However, look at this. I've specified the entire IPv6 address, 2020:1::, which means a whole bunch of zeros, and a 1. /64 means the first 64 bits are the network, the last 64 are the host. And then I said EUI64, and the Cisco router would balk and say, oh, wait. You want me to use EUI64, but you specified the address there. That's not going to fly. And that's why these two answers are the only correct ones on the board. All right, let me clear that off. Very exciting times. And the leaderboard. Oh, Lucky Tiger got knocked off the top. Super Iguana, #1, followed by Super Yeti, Fast Falcon, Lucky Tiger, and Dynamic Koala. Sounds like an oxymoron there, but okay, here we go. Moving forward, here's question 4 of 10. We are on a roll. How do you hard code an IPv6 link local layer 3 address for gig 00? So IPv6 address FE80::1 space link-local is how you literally hard code a link local address. It's still layer 3. So if we have a global address, that's a layer 3 address. If we have a link local address, that's a layer 3 address. If we have a unique local address, that's a layer 3 address. And then it also has ability to resolve what layer 2 addresses is. It doesn't use ARP, it uses neighbor discovery for that. But global addresses, just as a reminder, this may help on some other questions coming up. It starts with 2000 through 3 FFF. I would commit these to memory. Link local is FE80, starts with that. And a unique local is FC or FD. And then, you know what? What the heck? Multicast addresses start with FF. So if we had a FF, that's always going to be a multicast. Then we have the next two characters. And if it's a 2 in that fourth character, which is the fourth grouping of 4 bits, if there's a 2 there, that means it's local. So a broadcast, if it's sent to FF02, that means if we had 3 routers, I'll call it A, B, and C, just 'cause I want to mix it up. And router A sends a multicast to FF02, router B is never going to forward that over to yet another network segment. It's non-routable. It's a multicast for the local segment only. So protocols like, I don't know, IPv6 use a lot of multicast, including for routers and devices that are speaking IPv6. And some of the well-known groups, multicast groups, would include things like FF02::5. That'd be great for OSPF. FF02::1 would be all IPv6 speakers, every device that's running IPv6, every interface. And then ::2 would be routers that have IPv6 unicast routing enabled. Alrighty, that's good for a few questions. If you want to hang on to that information, it's all about learning and getting better and better and better. I'm so glad that you're all here. I'm thrilled. All right, here is the leaderboard. Super Iguana with 5,490 points. Oh my gosh, yes! Question number 5, halfway through. IPv6 addresses starting with what can be routed internally, but not externally? I wanted to congratulate all the people who have gotten their CCNA in the last week. It's been quite a few of us, so congratulations, way to go. I have a few people that mentioned they're going to be taking their exam coming up in the near future. So to everybody who is considering taking their exam and doing their final prep, I would strongly encourage you to use this URL. And let me just put it up here. It's ogit.online/quiz. Like that. ogit cisco.online/quiz, or even easier, you can just go to my channel, and I have got a playlist called quizzes. This is it. And that's just a short URL for it. And what I would have you do, this covers like it's like some questions you can just memorize. I'm not too worried about that. That's just some basic memorization. But as far as the concepts go, and do you understand it? I built these quiz questions for that intent, to help make sure that you understand. And it covers most of the blueprint, all 6 modules. And I think I've got currently 39 videos. And so you can just scrub through them. Just, so that's what I recommend doing before you take your exam. Not the day of, not the morning before, but like the 2 or 3 days before. Start going through, think about what your weakest areas are, and hit it. And then if you need some help, jump on Discord, ask for assistance, and you'll get it. So good luck to all your studies. And again, congratulations to everybody who's done so great in their exams. So let me clear that off. Let me move that out of the way. That's the sound of a window moving. Okay, IPv6 addresses. And I love doing this with everybody, and everybody from all over. In fact, if you would just, could you, if you haven't yet chatted in where you're watching this from, whether it's a state, country, whatever you want to put in, or city, would you just chat in where you're enjoying this quiz from? And that way, on the next quiz, I'll take a look at all the answers and just really enjoy the variety that we have in this community. And I'm excited for every single one of you. I was watching. Let me bring this up. I watched David Bomble's interview with Ivan Pepplejack the other day, and I loved it. And David was asking, what's the major, what's the things that people need to know? And Ivan said, well, for short term, if you learn automation and programming and stuff like that, that's going to be useful for a while, and probably for the rest of your career. But he said, if you're worried about long term, he goes, learn the fundamentals. Because then you're like an engineer who has, the pieces, the parts, they can work all together. And his opinion was that if somebody knows the fundamentals, you can work with a really excellent Python programmer someday who can script it based on what needs to be done and checked and looked at. And if you can do both, that's great too. But I loved it because the fundamentals I'm all about the fundamentals because it's going to change your life. It's going to change your life. And then in fact, the first time you walk into an environment and you can troubleshoot something because you understand how it works, like, that ping didn't work, but let's look at the ARP cache. Oh my gosh, it resolved the layer 2 address. That device that wouldn't respond to the ping is in the same VLAN because you got the layer 2 address. And so things like that are going to help you in your troubleshooting. And, once you start getting the fundamentals down, you can start worrying about overlay networks and how that all works and software-defined networking. It's a wonderful, crazy world out there. And the CCNA is a great foundation for that. So everybody who passed your CCNA in the last week, congratulations, way to go. And my coaching to you would be, don't stop. Keep on going. Graduate from this channel. Go on to CCNP, or if you want to go to like Palo Alto or Citrix or whatever vendor you want to, Citrix, I meant to say Checkpoint, or whatever vendor you want to work with, whether it's cloud, Amazon or Google or, Azure, do it. Just keep on going. And I love what Ivan Pepplejack said. He said, people say I don't have experience. And he said, do something. He's so great. So I would recommend, if you have a moment or two, schedule a few minutes to watch the interview on David Bomble's channel with Ivan Pepplejack, because he has great ideas on how to start doing something, whether it's volunteer work or whatever it is, to demonstrate that you can do something, and then you can get an entry-level job and hopefully continue your growth. All right, I'm taking off. Let me go back to that full screen, and let's take a look at this question. All right, IPv6 addresses starting with blank can be routed internally but not externally, and that would be this bad boy, which 38 of you got, and it would also be FD. I'll put that right here in the winner column. So these are the unique local addresses. Think of them like RFC 1918 addresses, and if you don't like RFCs, just think of them like private addresses, which is what that RFC is all about. So private IPv4 addresses, which include things like 10 anything, 172.16 through 31 anything, and 192.168 anything. Think of these two, think of FC and FD. Think of them like private addresses. You can route them in your organization, but the internet is not going to route them for you. They're going to drop them just because these are addresses that should never show up on the public internet. So FF02 is a multicast address, and the 02 means it's not being routed anywhere. And this is a global address, which can be routed internally and externally. That's why it's not correct. And the green one, FE80, is a link local address. And it's only good between, like, let's say this is router 1, router 2, and we've got a switch here, and we've had, 48 hosts that are sitting here. Link local is only good in the VLAN, in that domain, that network. And that's the only place it's good. Can't be used anywhere else. All right. Let me clear off that screen. And let me go. Yeah, I think we're set. Okay, here we go. Moving forward, here's the scoreboard. Super Iguana with over 6,000 points. You've got some competition. Ooh, look at this. Snowy Deer is the highest climber. Congratulations to everybody. Here we go. Question 6 of 10. Which of the following is a multicast address? You don't need this graphic for it. You just need the correct answer. It's one of these 4. All right, nailed it. FF02::5. That absolutely is a multicast address. And as a reminder, if it starts with FF, it's multicast in IPv6. The 02 in scope refers to the local segment, so it's not routable outside that local network. And the actual last part here, 1 is for all IPv6 interfaces. Now, that's just basically, so if you have a Linux machine that's running IPv6, it would have tuned into FF02::1. If you had a Macintosh or a Windows or whatever that's running IPv6 on its interface, it will have joined that group of FF02::1. If you have a router that's enabled for routing for IPv6, it'll have joined FF02::2. And those are probably the 3 that I want you to really remember. Also with this one, this is OSPF. And if you had a designated router on the segment, it would also, or a backup designated router, it should also, I say should, but I'm going to say should because Packet Tracer has a little bit of a hiccup with that. But anyway, in a normal environment, if you have a device that's acting as a DR or BDR, it will join the :5, which is all OSPF routers, and :6, which is the DR or BDR function. All right, here we go. Moving forward. Good job, everybody. Super Iguana will not relent. Love it. Appreciate everybody being here. Here's question number 7. It is multiple select. I'm looking for 2 factors, 2 issues that caused interface gig01 from this output to join FF02::5. Oh my gosh, I just explained this. I didn't realize this was going to be the next question. It's a mad rush. It's a mad rush. So you might notice that over the past 4 months, I've been doing tutoring during these quizzes. So it's not just, hey, you got it right, you got it wrong, but actually explaining and providing insight, because I want to make sure I'm always thinking about ways to provide additional value. How can I do it? And one way is to help reinforce the concept. So OSPF version 3 is enabled. That's the multicast group FF02::5 that it had joined. That's this one right there. And if IPv6 wasn't enabled, it wouldn't be able to join. It wouldn't be able to run OSPF version 3. All right, here we go. Next question. We have 8 of 10 here. What will be the EUI64 host address based on the interface gig 0/2? All right. Well, let's do this one together for a moment. We have 41 people on the right answer, and then we have more than 41 people not on the right answer. So let me bring up the graphic and let's just walk through this. I also want to share with you a little confession. I have to think through most of the things I still do today. Like, some people ask me, Keith, does it ever become second nature? And I'm like, no, not really. I mean, it becomes easier and easier, but I still have to put a lot of conscious effort into most of the things I do with IT. I do. I just doesn't like, oh, this is that. So if it seems like it's tough or you're struggling, hang in there. You can do this. If I can do this, you can do this. All right, so if we're going to take this address, and it says, what will be the EUI64 host address? So the first 64 bits, something over here, is the network. And so I don't even care what the network is. It could be 2001, DB8, for the network. And then for the host portion, if we're using EUI64, it takes this MAC address and it splits it down the middle, boink, like that. And it adds FFE in the very middle of that. And then it basically puts the bottom half of that there and the front half of that there for a total of 64 bits. So this is 48 bits. So it'd be 24 bits, plus 16 more makes 64. Anyway, that's how it works. But with EUI 64, they flip the 7th bit. Not my fault. Don't shoot the messenger. So if we look at 00, and I will put that in binary. Let me put that in a different color. So 00 in binary is 0000 and 0000. If you need a tutorial on binary and conversion, come check out my Subnet Saturdays course. It'll teach you all about that. So that's what it is. But if we flip the 7th bit, I'll put it in a different color here, and we went to 1, 2, 3, 4, 5, 6, 7. So if it was a 0, we're going to make it a 1. We flipped it. Now it would be 0, and this would be that's the 2 position. That'd be a 2, and our address would be 0, 2, E0, and then A3, and then FFFE, and then the C7B403 at the back end. And the leading 0 doesn't have to be shown. So if you're working with an IPv6 address, you can drop that leading 0, and it would look something like this. Let's see here. So let's see here. 1, 2, 1, 2, 3, 4. Good. Because an IPv6 address, there's 8 sections, and with the /64, 4 of those sections are to the left, and 4 are going to be for the host addressing. And so we should see 02E0. If that's a correct answer, I'll be pleased. There we go. 2E0 with the leading 0 dropped off, and that's how that's calculated. All right, move it. And you might be asking, well, Keith, how important is that to know? You might want to know that. That's all I'm saying. You just might want to know it. There's very, very little, if anything, that I do in these quizzes and on my YouTube channel in the CCNA playlist that isn't relevant for what a CCNA would want to be aware of and study. Here we go. We're nearing the home stretch here. Question 9 of 10. Which multicast group has gig 00 joined? All right, yeah. FF02::1. Everybody who's running IPv6, which that command would enable IPv6 on the interface, is going to join that all nodes multicast group of FF02::1. And if we enabled IPv6 unicast routing, it would join an additional group of FF02::2. And if we enabled OSPF for IPv6 on that interface, it would join at least FF02::5. And then, everything on the left there is not right. Okay, I think we have one more. Here we go. All right, here's our final question for this quiz. What happens when a host sends an IPv6 broadcast into the VLAN? I thought I took this question out. There's only 30 seconds. You better jump on this right away. Nailed it. All right, no broadcasts exist in IPv6. All right, that's it. Let's take a look at the winners table. All right, congratulations. I had a lot of fun. Putting these together. So a couple weeks ago, somebody recommended I do IPv6, so we did it for the office hour yesterday on Discord, and then we did the quiz today, but based on that as well. Here's the 2 toughest questions that were in the whole quiz. Which 2 commands auto-generate an IPv6 address, and which commands on their own can generate an IPv6 address, which are basically variants of the same question. All right, great. And let me go ahead and get some feedback as well. And yeah, if you just give me a little bit of feedback, that helps me as a trainer to better meet your needs. And if you need a bolt, that's great. I will stick around for a few minutes right here and answer questions. And then in about 5 or 6 minutes, we'll hop over into the Discord server for those interested. And we'll hang out with Donald Robb, who's amazing, who can teach us about VXLANs. It's going to be good. Kelvin and he are going back and forth on different topics. And they put a lot of, I'm grateful. When you think about a consultant, right, who could bill for hundreds of dollars an hour, and they're volunteering just to teach for free, just to help people, way to go. I'm very, very grateful. All right, let me go ahead and let me maximize that. Let me get the right camera. All right. And that'll be the end of the recorded quiz, which I did hit record, which is great. So the way this works is I am going, later today, I'm going to pull this video off of YouTube so it'll no longer be available. I have a recording locally, and what I'll do is I'll edit it and make it nice and tight and short. So it just has the questions, explanations where appropriate, and then it goes in the playlist called the quiz playlist, so you can enjoy it there.
What you're putting in.